Okay, when TempleOS is recognized as God's official temple, we want some companies to make some changes. The most immediate change we want is VMware to support PC speaker. They support it in, there's two products VMware makes, Player, VMware makes Player and Workstation. And Player 4 worked, but now I think they're up to Player 6, and it stopped working after Player 4. Workstation number 8 worked, and now we're up to 10 and it doesn't work. They intentionally removed PC speaker support. Now, not all computers have a PC speaker. TempleOS is primarily for desktops, and laptops are less likely to have PC speaker, but it's really easy for them to make emulation. QEMU, as a matter of fact, emulates. I imagine VMware would prefer to emulate all the time. I guess that's okay. I don't really care. Anyway. Now we want Windows and Linux in VMware to support. It has VMware mounts file systems, so they also anyway. If you know what a file system is, FAT32 is a disk. FAT32 is a read-write. ISO 9660 is a read-only. Currently, I support FAT32 and ISO 9660, and a file system called Red Sea that I invented. And here's the plan. We want God's temple to be perfect with no blemishes. So we immediately change any blemish, even if it messes up backward compatibility. And I have a vision for. This is a file system, and it's an absolute. It's a minimal file system. I compare it to a 1040EZ tax form. On a 1040EZ tax form, you don't put anything extra. This is supposed to last 1,000 years, and as a matter of fact, let me explain it to you. It's just like a FAT32, except well, it's similar to a FAT32, except there's no fat. there's a contiguous there's a bitmap for contiguous allocations for files. So files have to be contiguous. So that we read and write whole files. That's the way we operate. We read and write whole files, and if that's not suitable, go use Linux or Windows. TempleOS is a secondary operating system to be used. It's not networked, so we're not even close to being covering all your needs. So this is a special place that's kind of beautiful. It's kind of like the vision is a Commodore 64. If you remember when the Commodore was not pathetic, when it was in fact top of the line, TempleOS is 64-bit. Anyway, they had mainframes at NASA when they had Commodore 64s, and nobody confused a mainframe at NASA with the Commodore 64. So nobody's going to confuse this operating system with Linux or Windows. Now the philosophy is to make it easy for the kids to, okay, if I do a directory star comma true, then we get clusters. Okay, this is FAT32. Now that means we have to say dump cluster, and we can look at the directory cluster. Okay, so here's a cluster. There's the directory entries. That's a FAT32. It's really ugly. Now, when you have kids, we want them to edit the Red C, and it makes it a little easier if we can use blocks. So, like if we say dump block, cluster and block it's just an extra detail to get confused. Just like we simplified physical memory and virtual memory, virtual addresses, we want to simplify clusters and blocks. So anyway, so what I did with the Red C file system is I was using clusters. Now I'm just using blocks. As a matter of fact, we're going to change this to block as soon as we get everybody on board. I'm going to go ahead and make that change. So we want to get so this is, let me explain this. This is just about the simplest file system possible. You have a bitmap with individual blocks, not clusters. So it's not suitable for I imagine on a big drive with big files. It would be wasteful. However, we're not targeting that. It is 64-bit cluster numbers, so it's kind of, some people might say, why don't you use 48-bit? No, we're just using 64-bit. Anyway, so the directory entries have a fixed name length, 38 characters. It has a cluster, the file size in bytes. Then I have my own date time. You'll have to put that into Windows and Linux. I guess technically I could do the Linux driver, but I really don't want to do that. Anyway, so I have an implementation of my date time. You can just copy this code. So I have directories like FAT32, except they're fixed length 64 byte, and they're like this. And I have 16-bit attributes. So I have a few more attributes that I can use. Anyway, so we're not quite settled on. Like I said, we're pretty close to settled. When we talk about it, we can settle on any questions you have. And then there's a boot. The first block of the partition is the boot block. So as a matter of fact, right now we have a in the partition table, we call it FAT32, even though it's not. That's because a lot of systems only boot FAT32. They reject anything that's not Microsoft. So that's one. This is the first block of the partition. The first block of the drive, if it's a I forgot what you call it, the old BIOS. Now they have UEFI and a new booting system. But anyway, here's the plan. So we have an allocation bitmap, a single one. I'm not doing bad blocks. That's not the way we operate. We just reformat, and we're not doing bad block. We're not doing two FATs. We're just doing one. This is a kayak, not a Titanic. So we're not doing anything about bad blocks. Now we're so for the ISO 9660, what we're going to do is we're going to right now I have a file that makes an ISO file. We're going to make an ISO file that is we're going to you tell it a directory, and it puts it formats the ISO file is a Red C image. So so it builds a Red C image in the ISO for the CD-ROM. Or we're not doing multi-burn, we're just doing a single burn. And anyway, so here's what happens when we get Windows and Linux to implement Red C. Then we have a system that is no longer it's no longer virtual and normally you have a virtual file system because you have multiple individual file systems. Look what happens when we shrink down to just Red C. Look at how much code we get to eliminate. We get to eliminate. Oh, hold on. Let's look at a better one. So I have switch statements all over the place like this. So look what happens. All this code gets cleaned up. We get rid of all this stuff, and it's that much cleaner. So everybody should take joy in God's temple, and we can get it all cleaned up really nice with just blocks. And we get rid of FAT32, saves 1,000 lines. We get rid of ISO 9660, and then we just have the Red C. And we get rid of, we make this doesn't shrink as much as I hoped. We still need quite a bit to make an ISO file. Anyway, so moving right along. So we want Microsoft to oh, I forgot. There's another thing. Once we get rid of once we get Windows and Linux using Red C, then the disk code. We can get rid of all the cluster operations because they're just blocks. So now we don't need both. You see down here we have write clusters, write blocks, write clusters, read blocks, read clusters. We get rid of clusters. That'll be glorious. So it'll really clean everything up, and the little kids can have a beautiful garden to play in. Like when I was a kid and I followed blockchains on the Commodore 64. Anyway, so Microsoft has to cancel secure boot. We need to dual boot. We don't have networking. This is not acceptable. And you know how looking at a telescope, if you look in the lens of the telescope, that's different than if you're looking at it on the internet. You know, some people say, well, why don't you just look on the internet? No, that's not the same as looking at the lens of a telescope. Real hardware is different from a virtual machine. That's not acceptable. This is not what God wants. God said that they moved us off our ancestral lands. On the Commodore 64, we had direct hardware access, and they've moved us onto a reservation. And even though the U.S. got away with it with Native Americans, it's not going to happen with God's. That's not acceptable. You moved us off our native lands. That's not acceptable. Anyway, so they have to get rid of secure boot. Not acceptable. There's not going to be any more hackers now that God kills them. Anyway, so PC hardware manufacturers need to. Okay, so we want ATAPI port IO. This is like the old school IDE. Right now it works. If you're aware, the port IO is easy to do at another bank of port numbers, but we want to just standardize the ATA port IO for disks. Put it at the IDE. Put the hard disk on the primary IDE. put the CD-ROM on a secondary IDE. Okay, so because there's another 280 lines of code just screwing around trying to figure out which set of ports. Oh, there's even more than that. There's well, I think we still want this. There's the PCI BIOS, which is we are not going to do PCI devices. Anyway, but I just in case the little kids want to do PCI devices, then we provide access to PCI. Anyway, so the vision going forward, you know how there's PS2 and USB, and there's a TAPI port I/O, and there's PCI, and there's VGA 640, 480, and there's GPU. Right now we have two different hardwares supported. The first generation is still supported with the latest generation. Going forward, we're going to make, for the next 1,000 years, the hardware companies are going to make a new simplified interface to replace PS2. It's a cleaned up PS2. It's a cleaned up ATA, TAPI port I/O. It's cleaned up to minimize the lines of code for drivers. So we want the fancy stuff for Windows and Linux, but in God's temple, this little shrine that's beautiful, we want not only are we going to keep the simple, we're going to improve the simple, and so we're going to have, so we need PS2 emulation. I use real hardware at the moment, not fictional, but in the future we're going to make it better. We want low lines of code. We have a limit of 100,000. So right now VMware does not allow a TAPI access to CD-ROMs. We want to pipe that through. This is paranoia that's, I could be a conspiracy and say it's the CIA plugging Microsoft. I don't know who it is, but God says no. Anyway, so perhaps VMware and Intel can make faster. If we could have a way of getting fast in-outs for the TAPI port I/O, that would be great, because right now that's much slower than PCI. I imagine they could do that as some kind of virtual machine or hypervisor setting. Couldn't they make the instruction faster? It's pretty crazy, isn't it? But anyway, we want computers to have a reset switch and a fast boot option. And guess what? Why don't we just replace UEFI with TempleOS? That's poetic justice. You know how in the Bible there's Haman and Mordecai? Well, one guy was going to get the Jews killed, and he ended up getting killed. Well, these fuckers put ELF and a bunch of graphics file formats and made a big cluster-fucked, huge monstrosity. All it needs to do is boot. Anyway, so now we're going to replace UEFI with TempleOS. And now we call that poetic justice. And so VMware and the others are going to list TempleOS as an official. Well, obviously. Windows and Linux, BMP is clusterfucked. I made a simple format that's right side up, and I do 8 bits per. I do 1 byte per pixel, even though we have 4 bits, but we want a transparency, so we need 8 bits. And we want no palette. This is think of the children. This is like a 1040 EZ. Actually, we do have LZW compression, so I kind of lied. But so we want a new graphics file format. We want all Windows Paint and all the Paint programs to support it. Actually, what we need bare minimum is screen capture somehow. We want to be able to import a 16-bit one of these. Anyway, so I have the code here. You can get it on the website. It's a really simple GRA format, and we want a nice dictionary, and I imagine we want a bunch of other stuff. But so we want, just like Knuth, maybe if you reduce the line of code count by 10, then you get your name in the Bible, something like that. So we want to reduce lines of code. So that's God's glorious temple.